So let us start a review. We initially started with QTP introduction. In QTP introduction, we have seen what is OOP, what is procedural programming. This is available under QTP principles. So OOP, object oriented programming, anything that we see, anything that we work with, everything is treated as an object, and how QTP understands the object and what is the main requirement to understand the object. We came to the concept called add-in. Add-in is the file or exe used to integrate QTP versus application under test. In this we have also seen what are all the default add-ins. There are 4 add-ins from default. One is standard Windows, second web, third VB, fourth ActiveX. So what each add-in does, how each add-in, the properties are triggered by QTP, how it is recognized those properties, what are all the methods applicable under each object. This we have seen. We have seen with .NET add-in, those are all available add-ins. There are a lot of available add-ins. When you install QTP, you will be knowing those. Once we finish that, we know how add-in plays an important role in managing the objects. Then we moved on to QTP object spy. Purpose of object spy to know how QTP recognizes the object and its properties and supported method on that object. This we have seen. Here we understood 3 things. One is called standard object, non-standard object, and non-recognizing object. So when the class of an object exactly matches to the add-in class, then those objects are recognized as standard object. The advantage of standard object is QTP recognizes its properties and methods as defined by the developer. There will not be any ambiguity in recognizing the object. Non-standard object, QTP is not able to recognize the class of the object developer used to recognize the object along with the add-in. They generally call it as a custom class. In such situations, QTP recognizes that object as a non-standard object. It recognizes as Win object using standard Windows most of the time. In case if it is Java, it is a Java object. In case if it is a web, it is a web element. When the object is recognized under these names, it is considered as a non-standard object. The disadvantage of non-standard object is QTP doesn't recognize its properties, object's properties or methods as it is defined by the developer. There is a chance that QTP might miss certain properties. In case you have such possibilities, you can convert non-standard object to standard object, and it is possible in multiple ways. For standard Windows, using object identification, selecting the standard Windows add-in, you can see user defined. From there you can manage non-standard to standard conversion. In case if it is other than standard windows, you have a method called test extensibility. This will give an introduction in tomorrow's session. Test extensibility allows you to customize the class of the object as you require. So that is also possible to convert non-standard object to standard object. All advanced techniques are driven from here. Then we moved on to non-recognition object. Usually the object that is written or created, no objects. It is the programming is done through procedural programming. Then it is called non-recognition object because there is no object defined by the developer to recognize it as an object. We have seen an example of Minesweeper, how a smiley button look like an object to us, but how it is not recognized by QTP. Using virtual objects, we can manage non-recognition objects. Please note, while recognizing non-recognition object, it is not possible to convert add-in related issues to be converted as a non-recognition object into a recognition object using virtual objects. It is not possible. It is not the ideal way of doing it. In case if you don't have an add-in for a technology that your application is built, QTP doesn't recognize those objects. Sometimes it recognizes as a Win object or other non-standard object, but most of the time it doesn't recognize the object. In such situations, you cannot use non-recognition object, that is virtual object, to convert that object for identification. It is not advisable because virtual object, all the properties that is defined by the developer is not visible. This is, we have seen it as in the beginning of QTP introduction. Once we finished that, we moved on to object identification. Object identification, we have seen following. Under object identification, we have seen how to convert a non-standard object of standard Windows into a standard object using user defined. Under user defined, you can map the class name, and the class name can be mapped to any of the standard class available with QTP. This is one of the way we have seen, and this is available only for standard Windows. Please note, it is only available for standard Windows and it is not available for any other object environment, that is add-in environment. This we have seen. We are also going to see text extensibility using this information. It is a separate installer. You can see text extensibility accelerator. This is another way of managing non-standard object of web technologies, Java technologies, and manage it as a standard objects. How to do it? We'll give an introduction most probably in next session. Once that is done, we moved on to object repository. Under object repository, we have seen two types of repositories. One, object identification, one convert non-standard object to standard object using standard Windows add-in, because it works only for the standard Windows add-in. Then we have also seen configuring mandatory, assistive, and as ordinal and smart identification. So what is the importance of mandatory properties? Mandatory properties QTP uses by default. to recognize the object at the time of recording uses the properties by default to recognize the object at the time of recording. Once QTP is able to recognize using mandatory properties, and if it is unique, he stops his recognition with that. Then assistive properties. QTP, when mandatory property fails to recognize the object uniquely, then QTP takes the help of recognizing the object using assistive properties. Whatever the property declared in assistive properties, QTP tries to use that property to recognize the object. So in case assistive fails to recognize the object, he looks for smart identification. This is the hierarchy in which QTP operates. Looks for smart identification. Smart identification has two ways to configure. One is base filter properties. Second, optional filter properties. This is taken as second level of recognition mechanism. By default, for web objects, base filter, optional filter is default configured, pre-configured, whereas you can force smart identification for other object classes as you feel. Base filter properties, whatever you configure in under base filter, it has to match. And then optional filter, at least one of the properties has to match. This also we have seen under object identification. We went to object identification. We have chosen the class. In our case, it was a standard class. We went to dialog. We configured smart identification for dialog class object. We configured in this way: base filter, optional filter. This is the way we configured. We have also seen under web objects, all the objects are predefined with smart identification, or the object class are predefined with object identification. This is the way a page is recognized or configured by default. This is acting as a second level of recognition mechanism. When the primary recognition, we call it as a description properties, fails to recognize the object uniquely, then by default QTP, if triggered, smart identification is triggered. Then we have seen ordinal. Ordinal identifier has two modes. One is location, another is index. Location, we have seen, understands or recognizes the object closest to x-axis as 0, then 1, etc. Index, object who is currently active is recognized as 0, then creation time, first browser object is considered as creation time 0, second browser 1, third browser 2, etc. This is the way object identification properties, mandatory, assistive, smart identification, ordinal identifier recognizes the object. At the time of replay, description properties, at the time of recording, description properties or repository will have all this information available. Repository, entire repository is in the XML format. I'll try to open one of the already created object to show you how XML is configured for a including smart identification. It is an XML file, so you can manage repository using XML. This is how test extensibility principle uses to recognize the object. Now I opened the repository. I have to make it as a shared repository to export it as XML. Let me check. Okay, expose and replace. Export local objects. I am now exporting it. In this, it is considered as a TSR file. I call it as, say, some smart identification. From TSR file, I'll open this object. Under this object, I open that smart identification. Now I can export this object into an XML file. Export to XML, because the entire structure of QTP is an XML file. So I'll open now. These are all very important when you are into the advanced concepts. I make it as XML repository. Under this XML repository, I store now smart identification. Now there are total 14 objects. Number of checkpoints is 0, number of parameters is 0, metadata. Everything is stored over here. Now I open it in a normal XML mode. You can open it in the notepad or you can open it in the browser. So I open it now. This is the default method in which QTP recognizes an XML object or entire repository. If what you see it in the repository is coming from here. So in this repository you can see now QTP repository, object repository, QTP object repository is the reference. This is Windows flight reservation. This is the way the object is recognized. I close everything. All the objects you have to store it under this node. This is called first children or child of root. Root is object repository QTP rep : object repository is my first candidate. We call it as a root. Under root you have an objects, that is a second candidate. After that you have a checkpoints, you have a parameters, you have a metadata. Then when you get into objects, you have lot of objects and each object is defined with its properties, basic identification, replay recognition properties, child objects if you have any. This is the way the window flight reservation, this is the first tree. In that tree of our recognition, this was the first object that is recognized. Under this you have child objects. These are all the child objects. Data flight is one child object, menu is another child object, name is third child object, fly to, fly from. So these are all some of the child objects we recorded. At the time of recording, this has got recognized. First is reading the XML itself is important. So when you read the XML, the first one you see the object, class, window, name, flight reservation. The first tag under that object class, properties. The properties are nothing but recognition properties of that particular flight reservation. Regular expression window title, it is not hidden, it is not read only, type is string. Regular expression window class, is one window is. This is the four properties used by description properties you might have noticed where to recognize that window property. So he used those as recognition properties. Next, you have basic identification. This is my basic identification using which I try to recognize the object. Then you have a custom replay. This is the way the custom replay object looks like. Sim class string. This is my actual class of the object. This is how it is behavior. He stored under behavior name. So this is how he recognized the first tree object. Now we come to the child objects. Data flight, you have again properties. You have again basic identification, custom replay, then last updated when you have updated. So this is the first child object, wind object data flight. So if I now come down to our smart identification, you can see now here the object class fax order number. This is the way the data is. These are all the C data. This is recognized. Now I go to basic identification. Under basic identification, you can see that text native class is one window, is child window. The value of this is taken by QTP, and you can see smart identification algorithm which was not there for the other objects. This is why we said you have to record the smart identification after triggering it into the object identification. Otherwise, this algorithm will not get created. You can see base filter properties is native class, optional filter properties values are text, is child window, one window, then smart identification. Excuse me. Smart identification. This is the way QTP recognizes an object using smart identification. So next you have a custom replay string hash. This is your main object type class. So using this class he tries to recognize the object. You can see the way the QTP recognizes the object and put that in the repository. The value of those that is used is available under C data. C data is holding the value of each of the object properties, right? So basic identification, from basic identification he goes to the tag and takes the value, and using this value he tries to recognize the object in application under test. So very important, very useful feature of QTP, right? Now we move on to the next, that is we call it as repository. We move back to the repository. All questions, type it in the questionnaire, we come back. Now having said repository, there are two types of repository we have seen. One is called local repository. Second, you have shared repository. Local repository is stored with the extension BDB file. BDB file has, now we have seen that XML is nothing but the structure of the BDB. So inside, so XML structure is how he recognizes. Then you have shared repository which is .tsr file. This is the extension of shared repository. Now we have also seen how to manage repository through XML file as well. So these are all the advanced concepts to manage the repository. Why I introduced XML to you now is text extensibility uses that concept without your knowledge. So that is why I just given an introduction to that. Once we moved on to repository, then we gone to the record and replay mode. Record mode. We have seen 4 types of record mode. One is normal recording. There is also called high level recording, also called standard recording, also called default recording mode, context sensitive recording. So these are all some of the names given for default recording mode. Second, we have seen analog recording. Then we moved on to low level recording. Normal recording, QTP uses objects, its properties to recognize and replay. Analog recording doesn't recognize object. It uses keyboard or mouse movement. When we touched analog recording, there are 2 types of analog recording. One is relative to the screen. Relative to the screen, the mouse movements and keyboard movements are recognized using the boundaries of with reference to the screen. So the syntax is desktop dot run analog. Make sure on the syntax, very important from the perspective of certification. This is how the relative to the screen syntax is. Track 1 is a file. It is a collection of file under tracklist.dat file. It is stored under script folder using name tracklist.dat. It is encrypted file. You cannot open it and modify in this file. So next we moved on to relative to window. The coordinates here are recognized with reference to the window. So he used window as a base reference. So window logical name. Window is stored under repository followed by dot run analog followed by either track 1 or track 2. If it is a first recording, then it is track 1. If it is a second recording within the same analog, then it is track 2. It is a continuous number he generates. All these tracks are stored under tracklist.dat. So this is about analog recording. Then we moved on to low level recording. Recognizes the object along with its coordinates. This is about low level recording. Then replay. So during recording, we have seen the activity that happens in QTP. 1. It recognizes the object on which user performs an action. He tries to recognize the object using object identification for that class. To get into object identification, he uses an add-in. Add-in helps QTP to know what is the class of the object, and using that class, QTP tries to recognize the object using object identification class, defined properties, mandatory properties, assistive properties, smart identification, ordinal. Whatever is appropriate to generate the object uniquely inside the repository, he recognizes those. He moves that object into the repository and he gives the name, and the name that he gives is called logical name. He recognizes the object using logical name, and he recognizes the object inside the repository using description properties. Description properties is defined based on object identification declared properties in mandatory assistive ordinal smart identification. Once he puts all this, he generates the script with object.action mode. Object.action is the method he uses to generate the script. Once he generated, when you do replay, he tries to read the objects and methods from the script, tries to identify the object. If it is defined as a logical name, he tries to identify object using logical name inside the repository. It can be both shared or local. If he identifies logical name, then he proceeds to description properties, retrieves all the description properties, tries to identify the object inside the application using description properties. If it matches, then performs action on that object in the application under test. If it doesn't, he comes up with a failure. So this is the way the replay works. So here logical name is important. Logical name finally uses description properties. Description properties finally gets converted as a descriptive programming, and using descriptive programming he identifies the object in the repository. Object in the application under test. This is the way the replay works.